The second one is a little bit harder. Now, how many dice are you rolling?
2.
2 of them. So what you need to think of is in your first roll, how many possibilities, or what are the possibilities in your first roll?
1 through 6.
Yeah, 1 through 6 again. 4, 5, 6. I'm not going to write all of them out. We don't have enough room. We don't have enough time. But I made that really big. Let's say you rolled a 1 first. What could you roll the second time?
2, 3, 4, 5, 6.
Yeah, you could roll a 1, a 2, a 3, 4, 5, or a 6. So you could have rolled a 1 first, and then a 1, 2, 3, 4, 5, 6 second. Are we all okay with how that looks? You could do the same thing with 2. You could roll a 2, then you could roll a 1, 2, 3, 4, 5, 6. All the way through. So how many possibilities are there?
36.
There's going to be 36. Here's how you can figure that out without drawing the chart. If it says list the sample space, you see the word list, then technically it wants you to fill this in. I try to refrain from making you list a billion things. The most is usually about 20 where you would have to list. And I try to make them very, very few problems. But here's what you can do. How many possibilities are there when you roll the first dice? 6. How many are there when you roll the second?
6.
What is 6 times 6? So there are 36 possible outcomes. Okay? This is called the counting principle. And I'll tell you a little bit more about it in a second when we go over sample space. Before we do, we all need to be on the same page about probability. Okay? The probability, or a probability experiment, is your first blank. It is an action trial that has varying results. That is your first blank. A probability experiment. The possible results of a probability experiment are called outcomes. For instance, when you roll a 6-sided dice, there are 6 outcomes. We've talked about it. 1, 2, 3, 4, 5, 6. A collection or one or more outcomes of an event, or is called an event, such as rolling an odd number. You could say, what are the odds you roll, or what's the probability you roll an odd number? What would you say? On a 6-sided dice, what's the probability you roll an odd number?
1 out of 3. 18.
It's 1/2, because it's 1 is an odd number, 3 is an odd number, 5 is an odd number. So that's 3 out of how many numbers? 6. 3 out of 6 is 1/2, which is 50%. So that is called an event. It will tell you something specific to look for. That is an event. The set of all possible outcomes is called a sample space. This is what you want to highlight. It's one of the main things that we're going to talk about today. We're going to talk about sample space, number one thing, and then 2 different types of probabilities. Okay, the first one we'll do that in a second. We're going to talk about sample space. So, this top one you do have. The bottom ones we're just going to talk about. You flip a coin and roll a 6-sided die. How many possible outcomes are in the sample space? List the possible outcomes. Here's the easy way to do this. What is my first event that's happening? I flip a coin. So when I flip a coin, how many outcomes are there?
2.
There's 2 outcomes. What is my second event? Roll a 6-sided dice. Die. I hate that it's die. It's die instead of dice. I can't stand it. So if I say it, it is what it is. How many outcomes are there when you roll a 6-sided die?
6.
6. So how many outcomes are there total?
8.
Multiply them. There's 12 outcomes. We are going to list them. Sorry, that's all ugly. Outcomes. We are going to list them. We're going to use abbreviations because ain't nobody got time for that. So let's say we flip the coin. What do we get when we flip this coin? Heads. We're going to say heads first. I'm going to write H for heads. What could we roll then? Roll a 1. So heads and roll a 1, heads and roll a 2, heads and roll a 3, heads and roll a 4, heads and roll a 5, heads and roll a 6. Let's say we didn't flip a heads. We flipped tails. Tails and a 1, tails and a 2, tails and a 3, bless you, tails and a 4, tails and a 5, tails and a 6. Woo! So This is called the counting principle. You take the amount of outcomes in the first event and multiply it times the amount of outcomes in the second event. And that's how many outcomes there are total. If you don't like that, you can always list them. The problem with listing them is it's a lot of time, and you could miss one. This one's obviously easy, but sometimes they're harder. These next two are not on your notes. We're just going to talk about them. So find the number of possible outcomes in the sample space. A jewelry store sells gold and platinum rings. Each ring is fitted with a ruby, sapphire, emerald, or diamond gemstone. So we're going to say you're going to get one metal and you're going to get one gemstone. So how many options are there for metals? 2. There's gold and platinum. And then how many options are there for gemstones? 4.
Oh, I didn't see it.
It's okay. Third C. All right, so what do we do with those two numbers? Multiply them. 2 times 4 is, yeah, I don't know why I put 6. 8, my B. So that means you could do gold and ruby, gold and sapphire, gold and emerald, gold and diamond. Same thing with platinum. Okay? And then the last one is spinner can land on either red, blue, or green. You spin twice. How many options are there when you first spin? 3. And then when you second spin?
3.
Still 3. So 3 times 3 is 9 outcomes. Okay, you could get red and red. Red and green, red and blue, so on and so forth. Okay, are we all okay with sample space? Perfect. That leads us to probability. You can flip. There are 2 types of probability. One is called theoretical and one is called experimental. It is highly important to understand the difference. Let's think of the difference in their names. What does theoretical sound like?
It's
It-
not real.
Yeah, in theory. So we are going to prove one. Does someone have a quarter? Just find one, take it out, and we're going to work with it later. So what we're going to do later, not right now, is we're going to conduct an experiment flipping a coin. Here's the difference between theoretical and experimental. Theoretically, how often should I flip a heads?
50% of the time.
50% of the time. I'm looking for a percent. Because there are 2 options, and it's one of them. So 1 out of 2 is 50%. Are we all tracking? So what percent should I flip a tails? 50%. Later on, so once he has the quarter out, you good with the quarter? Whoever found it? We're going to do experimental later. What do you think happens in experimental probability?
The percentage changes.
It's going to change. We're actually going to do it. So in my last class, we flipped a head 7 times. And we flipped a tail 3 times. So we flipped heads 70% of the time and tails 30% of the time. So I'm going to show you the main difference. These are the last 2 things we're doing in this class today. Theoretical and experimental. Theoretical, you know how to do in your head, and I'll show you. Before we do, we're going to talk about those definitions that are at the top of the page. You're filling the blank. The probability on an event is a measure of the likelihood or chance that the event will occur. So you see this every day. If you want to go to the beach, what do you do usually? Or hopefully,
Check the weather.
check the weather. What does the weather usually tell you?
It's gonna be like,
If it's going to rain, how does it tell you? The percent of how much it's going to rain. So a lot of this, I'm going to bring back to the weather in a second. So probability is a number between 0 and 1, including 0 and 1, and can be expressed as a decimal fraction or percent. I'll explain what that means. Decimal fraction or percent. So when it says between 0 and 1, what are the only things between 0 and 1?
0.5.
Okay, 0.5, they're decimals and fractions. Okay? 0.5 is the same thing as 50%. So what is 1 going to be the same thing as? 100%. So if you end up getting the probability of something, and you get, like, let's say, I've seen it all day today. If you get 2 something, what is 2 made as a percent? 200%. Is there ever a likelihood, will the Weather Channel ever say there's a 200% chance that it's going to rain today? It will never say that, because it has to be between 0 and 1, 0 and 100%. I'll show you what we mean by that in a minute. So you need to use your common sense. If the Weather Channel told you that there's a 20% chance of rain, are you going to change your plans to go to the beach? Probably not. 20% is not very likely. If it said 80%, You probably are, okay, depending on the time of day. So use your common sense. You don't have to memorize when it says unlikely or likely. 50% is a flip of the coin, okay? It's a toss-up. So just use your common sense on that one. So theoretical probability, the official definition is going to pop at the bottom whenever it is done with this. Here we go. The outcomes for a specified event are called favorable outcomes. When all outcomes are equally likely, the theoretical probability of the event can be found by using the following. What do you keep putting on your desk? Yeah, put it aside. If you're hiding it from me, that means you know you're not supposed to be doing something. So the formula, which you'll want to highlight, the number of favorable outcomes over the total number of outcomes. I'll explain it to you. So the number of favorable outcomes over the total number of outcomes. That is Chris Schickman there. I can't. I'm not going to say anything. Alright, so what you want to write down at the bottom, it says the probability of event A. A stands for any event. What are the chances that I randomly select someone in this room that takes Spanish? What are the chances I randomly select a marble out of a bag that is red? Whatever. We call this P of A. Have you seen F of X before?
Yes. Yes.
Okay, good. That means function of X. This means probability of event A. So if you see P of A, this means probability of event A, whatever event. So on your homework, it says probability of rolling a 1 on a 6-sided die. So it would say this. So you would read it, probability of rolling a 1. Does that make sense? So whatever's on the inside is what you want to happen. So if you look at what I've drawn, you've seen a spinner before, hopefully, like
Twister.
Like Twister, yeah. You see a spinner? Yes? So on a spinner, what do you think red, yellow, I'm sorry. Yeah, it stands for red, yellow, green, blue. I was going to ask you, but anyways. We're going to find the theoretical probability of you flipping one of the colors. Pick a color.
Red. Red.
One green.
Whose birthday is closest to today?
Mine.
Is it though?
26.
When's your birthday?
May 15th.
When's your birthday?
It's definitely. Mine's May 6th.
May 6th. Anything closer?
Yes.
Pick a color. What do we want to spin? What? Want to spin a red? So you're going to put the favorable outcome is we want to spin a red. So this means what you want to happen. We want to spin a red. Out of the total number of outcomes. So the total outcomes. How many ways can I spin a red on this? One way out of how many total different outcomes I could have? Out of 4, which is what percent? 25%. Okay? So that's what you're looking at for theoretical probability. Will that actually happen though? Probably not. If you've ever played Monopoly, certain numbers are sometimes rolled a billion times and sometimes one number's never rolled. Okay? It just is, it's the luck of the die or the luck of the spin. Okay? So, we're going to find the theoretical probability of this problem. A coin is flipped 4 times. What's the probability that it lands on heads exactly 3 times? There is going to be math with this, so don't think like, oh, you're going to have to do something with this. So we're going to write down the formula first. So it's the number of favorable outcomes over the total number of outcomes. And we're actually going to find the total number of outcomes first. Okay? So total number of outcomes. How many events are happening?
4.
What are we doing? 4 events. So we're doing, in the first event, what are we doing? Flipping a coin, yes? How many outcomes are there when you flip a coin? 2. So that's the first time you do it. The second time you do it, how many outcomes are there when you flip a coin? Still 2. The third time you do it, still 2. And the fourth time you flip the coin, Still 2. So how do I find out how many outcomes there are? What am I going to do with these? Multiply them. So 2 times 2 times 2 times 2 is 16. There are 16 total outcomes. That could include flipping heads all 4 times, flipping tails all 4 times, so on and so forth. Are we all tracking the total? Kind of. Was that them outside? Okay, sorry, I was very confused. The number of favorable outcomes. So favorable means what we want to happen. What do we want to happen with our flips?
All heads.
We don't want all heads. How many do we want? Exactly 3 heads. So that could look like, so I'll give you an example. That could look like a heads first, heads second, heads third. What would the fourth one have to be? A tails. So we're trying to list them to see how many there are. What do you think another combination where we have exactly 3 heads? Sure. Heads, tails, heads, heads. Tails, heads, heads, heads. Did we get them all? Heads, heads, tails, heads. Are there any other combinations in which we have exactly 3 heads? No. So how many favorable outcomes where we have exactly 3 heads? There's 4 of them. 4 out of 16. So you can reduce this if you want, which is 1/4, which would make what percent? 25%. So it's not great, but that's not horrible either. Okay? So something I tell everyone. So we found the total number of outcomes to be 16 because we had 4 events and we did 2 times 2 times 2 times 2, yeah? Anything that has 2 outcomes in it. So flipping a coin, heads or tails, having a child, what are the 2 options, guys? Okay, that's no matter what happens. Anyways, winning or losing, forget about ties. Usually you win or you lose. Really, if you tie, you still kind of lose. It is what it is. True and false, 2 options. Anytime that happens, you can kind of do a shortcut. The total number of outcomes will be 2 raised to the number of trials. So how many trials or how many events did we have in this problem?
4.
So this would be 2 raised to the 4, which is the same thing as 2 times 2 times 2 times 2. So if you remember this way, that is perfectly fine. If you don't and you need to do the events, that is also fine. Okay, but it'll happen with anything, true and false, etc. Okay? All right, a complement. This one you have to flip. You have to follow me. Okay? A complement. So you remember when you learned the negation of a sentence?
Yeah.
The sky is blue. The negation was? The sky is not blue. A complement would say, find the probability of those in this class who take Spanish. The complement of that would be, find those in this room who do not take Spanish. Because you fit into 1 of 2 categories, right? You either take Spanish or you don't take Spanish, right? I don't take Spanish, so I would fit in the don't take Spanish category. That includes 100% of people, correct? So a complement will happen when you'll have event A. Sorry, I'll highlight it for you. The complement of event A consists of all outcomes that are not event A. So it sounds confusing. You do it in your head. I will show you an example. I want you to write down that and the little formula that will pop up at the bottom. And I will explain both. Just stick with me. We will all get through it. We will all understand it because I promise you, you do this in your head without even knowing. We'll do the complement of... We'll do this one. This one's easy. Okay. So it might say find the probability, because how many of you, this is not your first year at Trinity Christian Academy? Okay. The majority of you, this is not your first year, correct? So if I said find the probability that this is not your first year, it is easier to find those who it is their first year. Do we understand that? How many of you it is your first year at Trinity Christian Academy? You didn't raise your hand for either of them. Are you listening to me? This was a voting thing. Is this your first year at Trinity?
No.
I don't think so. This is your first year at Trinity? So where was your hand? This is your first year? So 1, 2, 3, 4. So 4, how many students are in this room?
24.
Well, students.
23.
23, because Emily's not here. So how many of you, without even counting the people, if 4 out of 23 of you, it is your first year at Trinity Christian Academy, how many of you it is not your first year? 19. That is called a compliment. That is all you are doing. When you see all of this lingo, what did I tell you P of A stood for? Probability of an event. So our event was that we did you not your first year at TCA. So the probability that it is your first year, we took 1. What does 1 represent in probability? 100%. We took 100% and subtracted the percent of students that were the opposite of what we needed. The reason being it was easier to find, to count, there was less people to count. That makes sense? All a complement is, these two numbers have to add up to 100%, because 4 plus 19 is 23, and 23 out of 23 is 100%. Okay? If you didn't get that, I will show you with numbers. This is not you. There are 20 people total in a group. Everyone put their names in the hat. Blue papers represent boys, and pink papers represent girls, as shown below. What is the probability to pick a male out of the hat? So what do you notice about these colors? Don't tell me the answer. What do you notice about the colors? There's mostly boys. So the easier thing to do is find out how many girls there are. And how many girls are there? 4 out of... It's okay. Out of 20. I thought Austin said it, not you. Sorry.
I see 2. I can't see.
It's okay. Of course you didn't. So if there are 4 out of 20 girls, without even counting, how many boys are there? 16 out of 20. That is all a complement is. So what percent are boys?
4, 5, 6.
16 out of 20. Go ahead and type it in. 16 divided by 20.
80%.
It is 80%. So then what percent were girls? 20%, because I have to add up to 100%, because you're either a girl or you're a boy. Gonna keep going. Here we are. If you don't see me on Monday, that would be why. Okay, what's the complement? So this is what you would actually see on your tests. They're not hard problems if you know how to kind of attack them. If you want to highlight that this will be on your test, so you remember to look at this. What is the complement if the probability of event A is 2 over 5? Some people don't like to think of it this way. All you're going to do is take the probability of this event and subtract it from 1. So what is 1 minus 2/5? 3/5. Here's what you did. What is 2/5 as a percent? 40%. Why can't I not draw? 40%. So you found that the rest of the population, whatever it is going to be 60%. That's all you're doing. It's just written in a fraction instead of written in percents. Okay? The second one is easier for a lot of people to see because it's written as a decimal. You do the same thing. 1 minus 0.12, which is 0.88. Okay? So that's all a complement is. We're going to use it in a problem. And you're going to see that you would have done it whether or not I told you what the word was. Okay? Our next, are we all okay? Do I need to go over it further? Doing all right? Okay. So, this is the last example of theoretical, and then we do some coin flipping. All right? So, 2 6-sided dice are rolled. We talked about this earlier. There are 36 possibilities. This is everything we did not want to draw earlier. So, roll to 1 second time. Roll to 1, roll to 2, roll to 1, roll to 3, blah. There. We want to find the probability that the sum is not 6. So that's kind of hard to find. So what could we find instead of finding the sum that is not 6? Find the sum that is 6 and then subtract it. So that's what we're going to do. Find the sum that is 6. Okay? So we're going to find a fraction. How many total combinations are there out here? How many total outcomes? 36. So this is a pair, a pair, a pair. So let's go ahead and look in the aisle of 1. 1 plus what is 6?
5 plus 1.
5 plus 1, so we got 1 and 5, 2 and 4. You're going to find a pattern. 3 and 2 and, or 4, and then 5 and 1. So how many of them the sum is 6? 5 out of 36. So how many do not have a sum of 6? 31 out of 36, which becomes what percent? 86%. Do you agree that that was something you probably would have done without learning the word, that this is a complement? Okay, it's kind of common sense that we just teach you anyways. So you want to erase on your picture so you can start fresh. We're going to find the second one. Give me 2 seconds. All right. Find the probability that the sum is less than or equal to 9. So what numbers are less than and equal to 9?
9, 8, 7, 6.
Yeah. So we don't want 9, 8, 7, 6. That's ugly. 7, 6, 5, 4, 3, 2. There's not going to be a 1, but 1. So instead of finding all of them that will have the sum of 9, 8, 7, 6, 5, 4, 3, 2, 1, we can find all the ones that are not going to be 9, 8, 7, 6, 5, 4, 3, 2, 1. So we're going to find all the ones that are greater first. Greater than 9. There's still 36 outcomes, so keep that in mind. So which corner, if we wanted to save a little bit of time, where do we want to start?
The left
Bottom
right.
right.
The bottom right. Because this is 6 and 6, which makes 12. So that's bigger than 9. You could move up or wherever. 6 and 5 make 11. 6 and 4 make 10. And then you're at 9 again. 6 and 3. Go to the next column. 6 and 5, which makes, and then 5 and 5, and then nothing. And then we have 6 and 4, so 10. So how many of them, they have a sum greater than 9? 6 of them. So how many of them are less than or equal to 9? 30 over 36 of them, which makes what percent? 83%. Sorry if my page is not pretty. I'm just trying to keep up. Okay, are we all okay with finding theoretical probability? This is all in theory. You should roll 2 numbers that have a sum less than 9. It's 83%. Does that mean it'll actually happen? Possibly not. Okay? We're going to be finished with the stapled, and we're going to go to the page. At this point, Trent, you have your quarter?
Yes.
We are going to show you what experimental probability is. Okay? So, on your new page, experimental sounds like something that has been tested, right? If you did an experiment in science class, you're testing something. So experimental probability is based on trials, repeated trials or tests that you're doing. Each trial in which that has a favorable outcome is called a success. So the formula, there's not really a place, you'll just have to write it in, and then kind of highlight it so you can remember it. Experimental probability is the number of successes over the number of trials. So number of successes over the number of trials. All right, Trent, you ready? Can you flip a coin? Do you want to come up here? How many times do we want to do this experiment? 12 times. Let's do it. Oh, that's fine. 12 is fine. Go ahead. Well, usually you catch it. Is that a heads or a tails? I think that's a tail.
That's tails.
All right, tails. Go ahead.
Flip it. Heads.
Heads. All right, we got 50-50.
Heads. Catch it. Heads again.
Does fail.
Well, you never know. Tails could make a comeback.
I think it's
Tails.
All right, there you go. See?
Heads.
We're at 6. We're halfway through. You stepped on it. It's okay. Just keep it.
Tails.
Let's
Or 7.
Tails.
Let's go.
So we're even.
Selling.
Tails.
Tails.
The next one has to be. Come on now. Come on now.
Heads.
That's what I'm talking about. Let's go.
We got 2 more.
Tails right here, bro. Oh yes, there roll.
Tails.
Let's
Come
go.
Come on, heads. Let's go. Come on.
Heads.
Let's go.
Do one more. Do one more.
Tails. Tails.
You do it.
Heads.
Yeah.
That's fine. I'm doing it because to show you that experimental is not always the same as theoretical. That one was pretty on the nose. So sometimes you can get, we only did it 10 times in my last class, but we got 7 and 3. This one is pretty down the middle. So experimental, you do the number of trials. How many times did we flip the coin? 13 times. How many times did we flip heads? 7. What is 7 out of 13? Type it in.
Ooh, I got
It's around 50 something.
53 or 54%.
53%.
54.
53.4%.
Wait, point 53.
What's after the 8?
That's confusing.
Alright? How many times, or what's the percent we flipped tails out of 13? We flipped it 6 times. So if you know, it's going to add up to 100. What is it?
46.
46.1.
No, 2.2.
So it has to add up to 100. It's okay. I appreciate you trying. It's supposed to add up to 100. So I'm showing you that we didn't do it based off of the amount of outcomes at all. We took our chart. We took how many times we did it. That was on the bottom. The amount of trials. And the amount of successes. So our success in the first one was how many times we flipped the heads. Our success in the second was how many times we flipped the tails. That's why 50-50 wasn't going to help you, because this is close to 50-50, but not quite. So we're going to do the bottom. This is what your homework would look like, a lot of it. So, this one. The sections of a spinner are numbered 1 through 12. Each section of the spinner has the same area. So why do you think that matters?
So they're equal.
So they're all equal. You have equal chances of spinning a 1 that you do a 12. Okay? You spin the spinner 180 times. The table shows the results. So I want you to write, what does the top row represent?
The number.
The numbers on the spinner. And what does the bottom row represent? How many times you spun it? How? I just can't. How many times? I just started writing a T instead of an M. So, the top row, the number that was on the spinner, your spinner is most likely a circle. This is not going to be pretty, just so we're all aware.
That's like a stamp.
I was just thinking.
No.
Nope, I don't know.
You're like the little Incredibles eye.
You look like the Incredibles eye.
Oh.
Okay, so that's what you're looking at. For which, because this is the question you're going to see a lot. For which number is the experimental probability the same as the theoretical? So what do you think we need to find first? We need to find the theoretical. Because we want to match the experimental of one of these to the theoretical. So theoretical, as if we don't see this chart at all, you have 12 numbers that you could spin. Do you have even chances of spinning all of them? Yes. So what's going to happen is outcomes goes on the bottom and favorable outcomes go on the top. So we said how many outcomes?
12.
12. How many spaces have a 1 on them?
180.
1. How many spaces have a number 2 on them? 1. So there's only 1 space with each of them. So there's only 1 chance to get any of them. 1 chance to get a 1, 1 chance to get a 2. So you're going to do 1 out of 12. Because there's only 1 of each. and 12 different outcomes. What is this as a percent? Round to the nearest tenth. 8.3%. So we are trying to match our theoretical probability of 8.3%. We're going to take the chart and see which one will match. So here's what we do. We take each of these numbers. How many times did they spin the number 1?
13.
13 out of how many total spins?
180.
180. So 13 out of 180, which is, you'll have to type that in. 7.2%. You go over 2 decimal places.
Okay.
It's okay. All right, so 7.2 does not match 8.3. We could try the second one, which is 21. 21 out of 180. What percent did we roll the number 2?
11.7.
11.7%.
Okay.
So here's where you can use your common sense. They spun this number 13 times, and it was pretty close to our theoretical probability. So we want to go from 13 and keep going a little bit more up and a little bit more up. 21 was way too big, so we want to stay near 13. What?
I say 14.
I would say 14. Okay, let's try 14. All right, so 14 out of how many spins? 180. What do we get? 7.8%. We're super close, not quite there. What do we want to try next? 15 out of 180. We get 8.3%. So what is my actual answer?
9.
The number 9. So it says which of the numbers, for which number, sorry it's written on, number is the experimental probability the same. So the number 9 is the same. So basically they all should have spun these 15 times each. But they didn't. One of them was spun 8 times. That's ridiculous. Don't bet your horses. So, this is where we will stop. We will continue this tomorrow. Did we talk about what you need to remember for tomorrow?
No call.
Your note cards. How many of them? 11. Good.